everybody, this is a quick video on operations with radicals. Um, Operations with radicals are not that difficult, especially if you know how to simplify a radical, which you should know from your previous lessons. So we're going to start with adding and subtracting. So adding and subtracting with radicals, the radicals must be alike. So it's a lot like terms with like term problems with the same variable with the same exponent in the same place. So for example, we're familiar with 4a and 2a. We would add the 4 and the 2, maybe we get 6a. Or 9b minus 2b, we'd subtract the 9 and the 2, we get 7b. Radical expressions are similar. The radicands must match, and we know a radicand is what's underneath the radical sign. So here we have 4 on the square root of 5 and 2 on the square root of 5. It's almost like we're teaching the radical, treating the radical and the radicand like a variable. We're bringing it down, and then we're adding the coefficients 4 and 2. Same thing with subtraction. So let's get started with some examples. Okay, so we're going to start with adding. Very, very simple. We add the coefficient, we keep the radical. So these match. We're going to keep the square root of 2, and then we're going to start 5 and 7 are going to add up to 12 on the square root of 2. And that's going to be our answer. Simple as that. Super simple, super easy. All right, our next problem, reduce subtraction. Same thing. 5 on the square root of 11 minus 7 on the square root of 11 is going to be 5 minus 7, which we know is negative 2 on the square root of 11. Just like that. That's all we have. Okay. And those are pretty basic examples. So what happens if they are not the same radicand? What if we have to simplify first? So you notice here we have 4 on the square root of 54 and 2 on the square root of 24. These are not like radicands. So what we're going to try to do is simplify them to see if they can become alike. So we're going to bring the 4 coefficient out, and we're going to start by breaking down the square root of 54. So we know that the product of two radicals is equal to the radical of the end result of the multiplying. So for example, we have the square root of 54. I always look at our perfect squares. As we know, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 25, 36, 30, 49, 64, 81, 100, 121, 144. We've got 169, 196, we've got 225, and the list continues. And these are all based off of the perfect squares 1 through 15, which you should have a list to do. So what we do is, here's how I like to do them. Find 54 on the list, right? The first number that's less than 54 is 49. Well, 49 does not divide into 54. 36 does not divide into 54. 25 does not divide into 54. 16 does not divide into 54, but 9 does. 9 divides into 54 6 times. So we look at both of these, and we have the square root of 9. Well, the square root of 9 is 3. We know that. So now instead of 4 times the square root of 9, I have 4 times 3. The square root of 6, we would break down into 2 and 3 because 6 is not a perfect square. Those aren't going to simplify because they're both prime. So we're going to leave this as the square root of 6. So this becomes 12 on the square root of 6. So we've basically taken this expression and we've rewritten it as 12 on the square root of 6. Let's do the same thing over here with 24. So this is all being added to 2 on the square root of 24. We're going to break the square root of 24 up. We're going to come through our list and we're going to say, okay, what number is smaller than 24? Well, 16 is, but 16 does not divide into 24. 9 is, but 9 does not divide into 24. 4 is, and 4 definitely divides into 24. In fact, it divides into 24 6 times. So then we look and say, okay, well, this is going to become 2 times the square root of 4 is 2. The square root of 6 would be 2 and 3, which we know is just the square root of 6. So we end up with plus 4 on the square root of 6. Now we have matching radicans. So we have those matching radicans. We can say, all right, 12 and 4 is 16 on the square root of 6 would be my solution. That is how we are going to do these problems. So if you need to, pause and get this copied down. All right, so I want you to take a minute, pause this video. After you pause the video, I want you to work this out and then turn it back on and let's check your answer. All right, so let's talk about this and see if you got your answer right after pausing to work it out. None of these are the same radicans, so we're going to break each one down. So we're going to keep the 2 coefficient and we're going to break the square root of 18 down. And if you use your list, the square root of 18 breaks down into the square root of 9 times the square root of 2, which we know the square root of 9 is 3. So this is bring down this 2 times 3 times the square root of 2. So this becomes 6 on the square root of 2. Plus, we're going to break down 2 on the square root of 32. We're going to bring down the 2, and we're going to split 32 up into 16 and 2. You're using your list. These should be pretty easy. Well, the 2 comes down. The square root of 16 is 4. The square root of 2 is just going to come on down. So we now have plus 8 on the square root of 2. And last but not least, square root of 72, we're going to break this up. What is a perfect square that goes into 72? That would be 9. 9 times 8 is 72. Square root of 9 is 3. The square root of 8 we could break up into something smaller. We can break this up into the square root of 4 times the square root of 2, which is the square root of 2, or the square root of 4 is 2 times the square root of 2. So I get plus 6 on the square root of 2. Okay, and now this one, 9 times 8 gives us 72. However, if we had checked, I went with 9 because I know 9 goes into 72. If you had checked on this, I think you would have seen that 36 also goes into 72, which would have saved you the extra step. So we did that. Now all 3 have the same radicand. So we keep that radicand, and then we're going to add 6 plus 8 plus 6, which is 20 on the square root of 2. And that is our solution. So that's how we add and subtract these pretty simple process here. All right, so what about multiplying? Multiplying is super duper easy. You multiply your coefficients and then you multiply the radicans. So you basically are going to multiply the 2 numbers in front. So 3 times 2 is 6. And then here we're going to actually deal with the radicand. We're going to multiply 2 times 6. So 6 on the square root of 12. We're not going to leave it as the square root of 12. We're going to simplify this by saying, hey, I know 4 is a perfect square that goes into 12. So this becomes the square root of 4 times the square root of 3, which the square root of 4 is 2 times the square root of 3. And we bring down that original 6. So my answer is going to be 12 on the square root of 3. So again, we're multiplying the coefficients and the radicands. So in this one, we're distributing each of these. So let's see if we can do this. 3 times 2 is 6. The square root of 5 times the square root of 5 is the square root of 25. All right, 3 times 5 over here is 15. The square root of 5 times the square root of 3 is the square root of 15. We're going to take a minute. We're going to look. We say, okay, I know the square root of 5 is 5. So this is 6 times the square root of, or times 5. Plus the square root of 15 would break into square root of 5 times square root 3. But those are not going to simplify, they're prime. So they're just going to leave this as is. So our answer is 30 plus 15 on the square root of 15. And that would be our solution. So we're distributing here, but we have to take into account the radical sign. All right, we've got one more set of examples we're going to look at. So again, what I want you to do is pause this video. I want you to try these 3 questions and then turn it back on and we'll check our answers together. Okay, hopefully you took a minute to pause this and work these out. So let's try these together. So the easy one first, 2 square root of 6 times 7 square root of 3. So we're going to 2 times 7 is 14. Square root of 6 times square root of 3 is the square root of 18. And hopefully you all knew that breaks down into the square root of 9 times the square root of 2, which is going to bring down the 14 times 3 times the square root of 2. 14 times 3 is going to give me 42 on the square root of 2. That's my solution. Okay, this one, same thing. 9 times 11 is 99. Square root of 5 times the square root of 15. The square root of 5 times 15 is going to be 25. Carry the 2, 75. We're not going to leave it as the square root of 75 though, because we know this breaks down into the square root of 25 times the square root of 3. If you're trying to figure out what radicals to break it down into, again, go to your list and say, okay, what's this number smaller than 75? Well, the first number on the list is 64. That doesn't go into 75, okay? The next number is 49. That doesn't go into 75. The next number is 36. That doesn't go into 75. But 25 does divide into 75, so we would use 25 times 3. So we're going to simplify this. The square root of 25 is 5. So I have 99 times 5 times the square root of 3, which should have given you 495 on the square root of 3. I'll check my math on that. 5 times 9 is 45. Here the 4. Yep, 495 on the square root of 3. So hopefully you got that one right. And the last one we're going to do is we're distributing. So we're going to do 5 times 3 is 15. The square root of 3 times the square root of 2 is the square root of 6 minus 5 times, this is understood to be a -1, so -5. 5 times -1 is -5. The square root of 3 times the square root of 3 is 9. So I do this, 15 square root of 6. Square root of 6 is not going to simplify to anything else. It will just break down the 2 and 3, which we can't do anything with, minus 5 times the square root of 9 becomes 3. So my solution is 15 square root of 6 minus 15. So hopefully you got those right. Hopefully you understand how to do this. Hopefully this video is helpful and you guys are feeling good about radical operations. Have a great day.